So in the previous video, we have seen how to solve the activity on the R problem. In the activity on the node, we are going to solve today, and we are going to find the critical path in the activity on the node problem. So problem basically looks something like this. They have given us different activities, and they also given the predecessors. Like if you say activity A, see the A is B said to be the starting activity, and for D, if you see D, B is said to be the starting activity. And responsibility, this is not something we are bothered with. Activity time, this is the time required for that particular activity. Previously, they have mentioned 1, 2, 1, 2, comma 12 means the arc's time has been mentioned, but here they said A, B, C, D, E, F, G, H, and all. So these are directly the nodes itself. The nodes cost itself is given, and the predecessors of the particular node is nothing but the connectivity which has to be finished before this has been started. So that has been given. Now we have converted that to diagrammatic form in this form. So these are the nodes itself. The same node and the R concept is the same, nothing is different. And each node, previously the cost was on the arc, but here the cost, if you see, it is below the node itself. Every cost has been mentioned. And as in the question, A and B are both starting. So both have predecessors as start. So we have given them as starting nodes, and K after K it is finish. So K after K, see, finish is predecessor for finish is K. That's why predecessor for finish is K. So this you have to just draw, but why we have done it in Excel so that it is easy to do, perform the action. Then again, the same thing, we have to do the forward and the backward thing. Before that, so this is the node structure in activity on the node path. This is just a structure, one way, graphical way to represent it. So this is the early start, ES. This is early start, this particular node. Immediately below it is early start. This is early finish, this value just above it is late finish, and this is late start. These are just the terminologies. You'll understand what early finish, early start, late finish, late start is. Early finish is basically when we are going in the forward direction, the cost which are coming is the early values. When they are coming from the backward direction, the values which are coming are the late values. So when we move from the, so okay, let us just simply move it. So when we starting from A, now we are going to start the forward. Same way, forward the same. Forward method for free float method to calculate the critical path. We are moving forward. Forward means we are moving from starting to finish. Starting doesn't take any time. So for A, what is the starting time? 0. 0 is the start. So early start is 0. Early finish means what? After the activity started, how much time will it take to finish? The time given is 12. So 12 will be required. But see, time is ticking. T is 0. 0 plus 12. So it is still 12. That is fun. Then for B, B is also starting at 0. Then what is B's early finish? 9. Why? 0 plus 9 compounds 9. Now, for I's early start. Early start for I is not 0. Why? Before I, there is a predecessor A. So A's early finish means after you are finishing A, you are immediately starting I. So what will be the early starting time for I? It will be 12, because that is when A is finished and you can start I. So this is 12. Then what is early finish for I? 12 plus 15, simple, 27. Similarly for F, what is the early starting time? Because A is its predecessor. So A ka early finish is 12. That will become the early start for F, because there is a connectivity between them. Again 12. Then what is the early finish for F? 12 plus 10, 22. Similarly for C is also having A as its predecessor. So its early start is 12. Early finish is 22, because 12 plus 10, 10 is the activity time required for C. Now for D, D's predecessor is B. B's finish time, early finish time is 9. So D will start after 9. So early start time is 9. And early finish for D is 10 plus 9, 19. Then for E, E is also B is the predecessor. So its early start is B's early finish, which is nothing but 9. Then what is the early finish for E? 9 plus 24, which is nothing but 33. Now we have constructed the first phase, second phase, all the phase early. Now we understood what is early start and early finish. Early comes when you are moving forward. Late comes when you are moving backwards. Now we have done the addition. Late we will do the subtraction. Simple. So the successor's nodes, successor means the one who comes after. Successor nodes, early start is the respective predecessor's early finish. Means what? I is the successor of A. I's early start is A's early finish. That's all. Simple. Then for G, so move stage by stage. This is ending stage. So let it leave it like that. This is in between. So for G, G is the successor of C. C's early finish is 22. So G's early start is 22. And what will be the early finish for G? 22 plus 35, which is 57. You can use Excel formula also. This is equal to 22 plus 37, simple. Then for H, the early start is 19. Then 40 plus 19, 59. Now come to J. Now if you see for J, for all these nodes, there is only one predecessor. I's predecessor is A. Predecessor means who comes before. F's predecessor is A. C's predecessor is A. Only one. For J, you have three predecessors. Now, this is a confusion. What should be the early start? We are moving forward. What we have done in the previous maximum value we have taken. Simple. Same maximum value again. Why? We have calculated the critical path. That's why we have to take the maximum value. Why critical path should be maximum? So that in crashing, we can reduce the duration. Why we want to reduce the duration of largest path? So that we don't have to face the penalty for not finishing the project within the time. So J's early start is maximum of 57, 59, 33. So maximum is 59. So 59 will be the early start for J. What will be the early finish? 59 plus 4 is 63. Then K, who are the predecessors? I, F and J. Similar thing, 27, 22 and 59. Maximum value is 59. 59 is the, sorry, 63 is your 63. J's early finish is 63. So that is the early start for K. Then early finish for K is 63 plus 6, 69. So this is the path we moved in the forward case. In the forward case, now we have found the maximum duration required to finish the entire project, which is 69 units. It can be days, it can be weeks, it can be anything as per given in the question. We speak on units. So 69 we are finishing from starting to end. This is the forward. Right. Now we move backward. In the forward, when we are starting, early start took 0, 0. In the backward, late finish will take 69. Because that is the maximum time it can take, no more than that. Now, late start is how much? Now, forward we have taken the plus. Backward we'll do the minus. So 69 minus 6, 63. Now, for J, who is the J becomes the predecessor for K. Now, same connection. 63 will come here. Why? Only for J, there is only, for J is only passing on to K. Forward node is only towards K. Backward is also, there is only one path. So that will take 63. Then 63 minus 4, again 59. Now, 59 is coming on to all these three things backward. So just fill them up. 59, 59, and again 59. Similarly, for these two nodes, I and F, they are the predecessors for K. So their late finish will be the late start for K. So 63, 63, then 63. Now, for G, 59 is here. 59 minus 35. That becomes the late start. 59 minus 35 is 24. For H, 59 minus 40, which is 19. This 19 again goes to D. D is late finish, 19. Now here C is predecessor for G. So this late start becomes late finish for C, which is 24. Now all these are filled. Similarly, just doing the subtractions. 63 minus 15, which is 58. Yeah, 48, sorry. 48. Then 63 minus 10, 53. 24 minus 10, 14. Then 19 minus 10, 9. 59 minus 24, 35. Similarly, now you see B's late finish. It is having two values. It can either take 9, it can either take 35. Now this is backward. Backward we take minimum value. So minimum of 9 and 35, it will take 9. Similarly for A, 48, 53 and 14. Always you have to see the bottom value because we are moving backwards. Backward value is late start. This late start becomes its predecessor's late finish. So 14. So 14 is your late finish. What is the logic behind it? This is the predecessor. Once this is finished, you can allocate these resources to here. So once at t is equal to 14, you have finished at C, the resources working on C could start working on A. That's why the value is the minimum value. Then 14 minus 12, which is 2. Then 9 minus 9 is 0. Now see the path. This path in activity on the node, what are all the critical values? Critical values forming the largest path from starting to finish. They are B, then it is D, then it is H, then it is J, then K. So B, D, H and K is your critical path. See the values early start, early finish, late start, late finish for B, D, H, J and K. The late start, early start are same, late finish, early finish are same. Late start, late finish same, early start, early finish, late start and early start are same, late finish and early finish are same. Late start, early start same, late finish, early finish same. Similarly for J, similarly for K. This is become your critical path. This critical path has to be minimized. The time duration is to be minimized so that you don't have to face the penalty. That is called as crashing. Before crashing, we'll do the PERT in the next video.